This is a brief overview of the BK Precision 8522 DC programmable load, and we're going to test it with this DC power supply, the Magna Power Electronics. This is a 0 to 200 volt, 0 to 20 amp power supply, and we're going to feed the load with this just for easy test purposes. Here we go. Here's a look at the back of the 8522. You can see it's got a standard AC power plug like here, and then it has a COM TTL here and another connection for communication that we're not using. You can notice that this cable is pretty small gauge. That's because this is a resistive load. It doesn't regen back to the grid. So you can see all the heat sinks inside. All the heat is dissipated and goes into the air of the lab. So back at the front, you can see that the connection terminals for the load are in the front. I've got a set of 10 gauge cables coming from the DC power supply to here. They're simple Allen bolts threaded into this. Because they're on the front and we're going to be using the front panel, I'm just going to use a simple cover so that there's no possible contact with me, so that's safe. Okay, so I'm going to go over the DC power supply first. Turn that on. Okay, you'll notice that it says standby in orange. That means that the output terminal is not turned on right now. If we press the V/I DIS button, it will display what the voltage and current settings are for when we push the start button. So you can set up what you want before pushing the start if you want it to come on to a particular value immediately. So for us, we want a 30 volt, 15 amp. That means that it will limit the output current to 15 amps, and the output voltage will be set to 30 volts. And I can turn on the load now. Okay, when I push the green start button, it's going to go into power mode. You can hear a click of the connection, and the output is 30, which you also see on the load. Okay, so the first thing we'll try is a control current. If you see the button, it says I-set, that's for current. If you push that and then type in 1 amp and hit enter, you still have nothing because you haven't pushed the on-off button. It's the same as the start and stop. So we push the on, we're drawing 1 amp, that shows up on the DC power supply. Okay, and you can use the knob to increase the value if you want. And there's different settings on how the knob increments. Right now it's doing increments of 10 milliamps, and you can change that if you would like. So I'm going to go ahead and push off, and now we're going to do a current setting of 5 amps. Okay, and push on. Alright, so this is constant current mode. So if I change the input voltage with this knob up to 35 and 40 volts, you can see the current stays the same. And if we go down all the way to 10 volts, still 5 amps. So the load is doing what it's supposed to be doing. Let's go back to 30. Okay, so that was constant current. Now I'll do a constant power. Let's do 100 watts. P-set 100, enter. Okay, and turn that on. So this one will be a inverse proportion. If we decrease the voltage, we'll get more current. we're down to 10 volts. We put in 100 watt reference, and we're getting 10 amps of current, so that's 100 watts. That's right. You can see the inverse proportion. When we go back up to 30 volts, we're only at 3 amps. Okay. All right, so there's a constant power load, and we can change that on the fly. We do 200, hit enter. So that was without doing an on to off. I'm going to change it back to 100. Okay. All right, let's go to the constant resistance R set. We'll do a 10 ohm load. R set 10. Enter. Okay, so that should give us 3 amps at 30 volts. Sure enough. Okay, so then this should be a linear proportion, so when we go down in voltage, we should get less current. Okay. We go up in voltage and we should get more current. Okay. And you can do the same thing. Change that to 5 ohms. You can change that on the fly. Okay. All right, the last test is the constant voltage. So the application for this is somewhat obscure. Why would you want to do a constant voltage loading? This comes out if you want to do a sort of a braking on a DC link for a motor drive. So say you have a reference voltage of say 300 volts, but the motor drive is bidirectional, and you want to prevent the voltage from going over 350 volts. So this will sink current to maintain voltage that you set. So on this test, we need to double check our current limits, because it's going to draw that much current as soon as we set the voltage over the voltage limit. So let me set this back down to 18 volts. Okay, we'll go to V set, and we'll do 20 volts. Okay. All right, so when we hit 20 volts here, you'll see the current go all the way up to the limit. That's why we double check that our current limit is actually set. Okay, so this would be a case where your DC link would be 18 volts, which is impractical. But then if you're regen from the motor drive, it's going to start climbing in voltage. As soon as you hit 20 volts, it's going to start sinking current so that the voltage will come back down. This is just a voltage supply, so it's not a. Forgot to turn on. Okay, so now it's in constant voltage mode. You can see it goes all the way up to the current limit until we go back down below the limit. And right now it's not drawing any current, and then as soon as you go over the limit, it's going to try and draw current so that the voltage will go back down below 20, but because of the supply, it's not going to decrease in voltage. So there's constant voltage now.